Thank you, Sam. Thank you, everyone, for coming. I'm sorry I couldn't be there. I had the best laid plans. And then my training got canceled, and then my conference talk got canceled, and I was just like, wow, this trip's really not working out. So thank you for having me anyway. Um, Today I want to talk about 30 tips for secure JavaScript. And there's actually more than 30, but 30 sounds really good in a talk title. So, what are we going to talk about today? Writing better JavaScript, right? And I think secure JavaScript is better than insecure JavaScript. We're going to talk about what to do and what not to do. As a bonus, we're going to talk about some free tools. And at the end, I'm going to have a bunch of cheat sheets. So I'm going to have QR codes with cheat sheets for Vue.js, React, and JavaScript. Although there's a big React vulnerability this week, in case you haven't seen it. If you're using React for your back end, run, don't walk, and go make an update. And that's not in the cheat sheet because I haven't updated it yet. But anyway, um, these are some of the job descriptions I see on the internet. And for now, the mandatory About Me slide. So this is the slide that presenters do to introduce themselves, to try to show you that we are competent and that maybe it's worth sitting through our talk. So I am a secure coding trainer at my own little tiny company. I have written 2 books, like Sam told you. I started in tech in 1997, which is quite a while ago. I founded some things. I'm founding a new company that is hopefully opening late February, early March. I'm an advisor to 2 startups, Smithy and Catalyst. And Smithy is out of the UK, so you might have heard of them. I'm a contributor to the OWASP Top 10 project, and I write for Stack Overflow, and I write for all sorts of different places. I'm a board member at the Forte Group, and hopefully you're like, she seems tolerable. I already came to the meetup. I might as well sit through this. So enough about me. Let's talk about JavaScript. JavaScript's the front end of the entire internet. It's what makes the internet responsive and beautiful. The internet was so lame before JavaScript with our BBSs and like static text and things taking 12 years to load. JavaScript is gorgeous and it makes everything amazing. It's wildly popular. I mean, obviously, so is the internet. But it's also riddled with cross-site scripting, which is an injection vulnerability that only happens in JavaScript. And there's other problems too. And I want all of us to write better, more secure JavaScript. So in case you missed the giant memo, which you probably didn't, because you are at an OWASP meetup, and usually I give this at dev meetups and dev conferences, secure coding matters now. Customers are not willing to tolerate wildly insecure things. Like they will not put up with that anymore. My parents bought a smart TV and they said, guess what, Tanya? It's been pen tested. My parents, that's awesome. If in Canada, the stats are that if you're a small business and you have a cybersecurity incident, 50% of them go out of business. It's really serious now. Plausible deniability is just, it's not a thing. And so if you're at OWASP, you probably know we need to build and maintain user trust. We need to meet compliance standards. We must protect our users' data. We must prevent business disruption, all the things. And we do this by building safe applications. And with that, there's secure design and secure code, right? We design it securely and we implement it securely. And today I'm going to talk about implementation. And so, without further ado, the actual talk. The best thing that we can do to help us automatically make way more secure code is to use a framework that automatically outputs and codes for us and offers tons of other super cool security features. And some good ones are React, Angular, and Vue.js. And I know I just told you there's a big vulnerability in React, but overall, it's still really a win. And the React team has handled it gracefully, quickly and very professionally. They've been doing everything they can to get the word out. They fixed it like immediately. They're doing a really good job. When it outputs in code for us, we don't even have to think. It's great. It just does the magic. However, if we're going to use a framework, it's important that we avoid potentially dangerous functions like React's dangerously set in our HTML, Angular's bypass trust as function. And so I'm going to give you cheat sheets for Vue and React. I don't have one for Angular yet, I know. I just haven't got around to it at the end, and one for JavaScript as well. But basically get to know the do's and do nots for them if you're going to use them. There's so many super cool, awesome features, and a lot of them have to do with security, and they're so totally worth doing. The next one for JavaScript and every single other programming language is that we should follow a secure system development lifecycle. So this means, to me, every phase of the system development lifecycle that we do, there's one or more security activities. And so during design, you might do a threat model. During the requirements phase, there might be security requirements that you add to the project. You might do lots of different types of scanning on your code. You might have plugins that help you while you're coding in your IDE. You might take secure coding training. You might read books. You might go to really cool meetups called OWASP. When you do your design, you might have a meeting to analyze the security of the design. You might have a secure architecture review process. There's all sorts of things that you can do. But the key is doing it every single time. And that is basically, if you do a secure system development lifecycle, you will create significantly more secure software. And I know it seems like a lot of work up front, but it's a lot less work in the long run. Number 3, I want us to take cross-site scripting seriously. If we could perform input validation, output encoding, and use the content security policy header. Also, if we could set the HTTP only flag on our cookies as a bonus, that would be great. Cross-site scripting is the only attack that all it works on is JavaScript. That's it. TypeScript actually transpiles into JavaScript. And so still cross-site scripting JavaScript only. Let me dig a bit deeper here. So cross-site scripting, or XSS as we say for short, is when your app confuses user input or data for instructions. So it thinks this is my code. Oh, I should interpret this code. No problem. The browser is going to run that for you in a jiffy. And what happens is, well, injection, right? It's a form of injection. The reason why cross-site scripting has its own special name is because every other type of injection happens to us, the IT team. Database injection, us. Operating system injection, us. LDAP, us. Those are attacks against us, and then we have to handle it, and it sucks, don't get me wrong, and users can still get hurt. But cross-site scripting happens on the person, like the user's own computer, and their own browser attacks them directly. And I don't know how to explain it, but it makes me feel much more embarrassed and ashamed to have my customers attacked directly. And so it gets its own name because it's a very special type of injection, and because it used to be so prevalent. It used to be in 2/3 of all web apps, and it's gone down, down, down. It used to have its own item on the top list. It's not even on there anymore. It's woven back into injection now because it's happening so much less. And part of it is because we're doing such a better job. But I still need us to all take it seriously. So to repeat, input validation. So the input validation is, are we receiving what we're supposed to be receiving? And maybe you need to accept special characters, and maybe you don't. But if you do, then either you sanitize them out, which is not what I do. I escape them. So escaping, basically you put a backslash in front, take away its superpowers. Then we do output encoding. And what that does is also take away superpowers. And it says, this is just text. It is only for display. That is all we shall do with it. And then on top of this, we use content security policy header, which is a security header that lets us list many things. It does many things. It's very powerful. But the biggest thing that people use it for the most often is to list all the external resources that we plan to use as part of our site, especially scripts. When you have cross-site scripting, a malicious actor first is like, do they have XSS? Great. How do I trigger it? Awesome. And then the first thing they do is they see if they can steal your session cookie. And after that, and if you have the HTTP only flag on your cookie, that's over. JavaScript can't access it. You're all good. And then the next thing they do is they try to call out on the internet to somewhere else and call a malicious script. Because usually like the field that you're given has, 50 characters or 250 characters or something like that. And that's not much code to do awful things. They want to do lots of bad stuff. So they call out somewhere else. And then content security policy is like, no. And so with this recipe, we can do a lot better. So I'm going to stop talking about that for a few minutes. Okay, so we would like to avoid inline scripting, where we mash our JavaScript and our HTML together in a big mess. We used to do that back in the day, but now we have separate files. If we do that, then we can add our JavaScript files to our content security policy header, right? It's similar to inline SQL when we combine a whole bunch of things together and then we send it directly to the database to get executed. It's a mess. We don't want to do this. Now, if you must, so if you're building a new app, don't do it, period. Don't do it. It's not best practice. Don't do that. But if you're opening up an old app that's like 500 years old and you have to fix a bug in it, you probably don't have time to separate them and rebuild the app. That's not reasonable, right? You're like, I'm just supposed to fix this tiny bug. So what you should do is use quoted variables. What that says is what's inside of here is text. It is not code. It should be treated as data and it should not be interpreted. And I'm going to give you a bunch more examples of what to do for that specifically, but the key is text and you explicitly show the JavaScript, hey, that's text. Just thought I'd tell you again. So number 5, we want to treat user input as something to display or save, but not something that we use to make key business decisions. If we didn't make so many business decisions based on user input, cross-site scripting would probably go away. If we could use this as like a rule or guideline, so we get something from the user and we try not to make a decision with it, or if we do, it's always against an allow list. And so user input, as a reminder, is anything that the user could have changed or touched. And so if you have a hidden field, that's like saying to malicious actors, go look here. If there's, parameters in the URL address, people are going to change them, right? So anything that the user could have got their little mitts on, that's user input. And that is something that we need to be quite careful about. That's how injection happens, yes. Okay, so going back to telling everyone text is text and making it extremely explicit to the interpreter, this is not code. Do not execute this or interpret this. We could use text content or create element rather than inner HTML or outer HTML. Those functions render stuff. Inner HTML and outer HTML render things. It's saying, go interpret this. So don't put stuff there that's from the user. Instead, use text content or create element. That would be safer because it says this is text. It specifies. New topic for a bit. So if we could use encode URI component and decode URI component as a matching pair rather than escape or unescape, we would have less opportunities for cross-site scripting. So escape and unescape are older, and I believe that escape is actually deprecated by now. If we put a URL in there, it could potentially bypass the safety in there. When we do, we break it down by component, each piece of the URI. It's safer, it parses better, and attacks don't get through as often. There are all sorts of types of attacks happening against URLs all the time right now. And so by breaking it down piece by piece, we will be safer. Ideally, we would use create element and append child rather than using document.write because document.write is dynamic. These functions, create element and append child, avoid inner HTML, and they use element properties, which are static rather than dynamic. So they'll use like text content or set attribute, and those are a lot safer. As a bonus, create element and append child also offers super fine-grained controls over the elements and the attributes and the event handling, and they work with more modern frameworks. Document.write is basically obsolete at this point. So if you see document.write in some old code, maybe you will change it. On top of that document.write, if you mess it up, it could potentially overwrite your whole page and just totally completely ruin your entire day. So we should avoid using it. We should not use unescaped HTML. So that is also, it's not standard JavaScript. It's not a best practice. It's not something we're supposed to be using anymore. It doesn't decode things quite right. And what it means is it could allow dangerous characters in by accident, which could potentially lead to cross-site scripting and other attacks. And so if instead we could use the he library or use Lodash, those are a lot safer. Honestly, unescaped HTML can also be confused with unescaped, which is deprecated and also bad and something else we're not supposed to use. So if we could not use that, that would be awesome. And this is going to be on the cheat sheet at the end. So again, back to decode and encode URI component. If we could do that rather than just the plain decode and encode URI, again, it's safer. So why is it safer? URI component is any part that lies between the separators. Every single part of the URL is a different component. The separators are encoded also because they are part of the text and they're not considered special characters. Each component also is capable of decoding more characters, including special characters that we may want to use. When we use the decode URI component function instead, it prevents incorrect parsing, which sometimes results in cross-site scripting. If we decide we want to use decode URI or encode URI, we should only do it if we know we have a complete URI that we are certain is complete and that we have validated manually ourselves in other ways. So basically, if we're willing to do a lot of extra work. So if I were you, I would skip it and just use the one with component instead. 11. We want to make sure to URL encode data before we pass it to the CSS URL method. So CSS is not a programming language. It's not its job to encode things and program for you. It makes things pretty. Its job, it's like makeup. It's not functional. It's just decoration. And so sometimes developers will send URLs there and think, oh, it's going to parse it and encode it for me and handle it for me. No, it's not. It's not smart. It's not going to do it for you. It will treat it as a literal URL or file path and just go on and do it. So it's not CSS is not a programming language. And so we need to not try to make it do that work for us. So if we could remember this one thing with CSS. Okay, so when we are in the DOM, which is the execution context, we need to do double encoding. We need to URL encode, and then we need to JavaScript encode. Yeah, we have to do it twice. And yes, it's gonna suck. If we are using user-supplied data, we need to be extra careful with anything, like with a URL that we are going to put into the DOM. I mean, ideally, we could just not put URLs in the DOM. Okay, 13. We would like to take away the superpowers between the script tags. So if we are doing inline scripting, which obviously we're not building new apps that way anymore, but when we're opening up an old app and we're fixing bugs, we want to use something like text content assignment property to set the text or the string content. So we're making it very specific. We're taking away the superpowers that it might have to ensure it's not interpreted. And so as an example, we would say, whatever your element is, dot text content, and then you just whatever it is that you want in there. That takes away its power. Because we've said this is text, this is text, that's all it is. We've made it explicit. Whenever things are implicit or implied, and we're trying to let the DOM or JavaScript itself figure it out, That's where mistakes happen. We never want ambiguity in computer science. Okay, so number 14, specify text as text. So especially when the text is from the user, because quite often, like when we're setting these things, it's from a variable, and it's a variable because it could have been changed, and who could it have been changed by? From an API we called, stuff we got from some database somewhere, from a user. And so it's potentially untrustworthy. And so when the text is from a user, if we use inner text or text content instead of inner HTML, again, we're not letting the DOM decide for us. We're being extremely clear of exactly what we want with our instructions. It's always specific that it's text because the DOM, it can make mistakes. 15, when setting element.setAttribute, we want to use safe static attributes. So here's a whole bunch of good ones. All of these don't change. So if you put something from a user in there, which obviously you should have validated first, right? Because that's what we do. We validate our input. And if we have to accept special characters, we sanitize or escape it. And then we put things in there. But these are safe. They're static. They're not going to change. But ones that are dynamic, like on click and on blur, that's where cross-site scripting loves to hang out. Guess where else it likes to hang out? More unsafe attributes, event handlers, on click, on change, on mouse over, etc. Something's happening. Form controller values, like selected, disabled, read only, href, source, action form, and even Boolean flags. Basically, if they are there, then they're considered true, even if you mark them as false, which is confusing. And basically, malicious actors have used that to cause cross-site scripting. And so we don't want to put user input into any of these. So when we're making bad choices, and by that I mean doing inline JavaScript, because we've discussed how we don't do that anymore on new apps. If we're going to use JSON, we need to say explicitly that we're using JSON. So we verify the content type header is set correctly, and this helps prevent cross-site scripting. We don't let it guess. Whenever we leave things ambiguous, things get upset. And so it's important we say it's application/JSON to make clear that that's what we're doing. Number 17. Variables, and by that I mean user data, go into the properties of cascading style sheets, not into the contexts, right? Contexts could be interpreted, but values are displayed. So for instance, property is this. If we put things into the properties, those are static, and then life is safer. We should turn on strict mode. That is all. Any language that has strict mode, we should turn it on. It enforces stricter parsing, error handling. It prevents accidental global variables. It blocks the this function, which binds to global variables and just makes a mess out of static analysis. It prevents us from deleting undeletable properties for objects. It helps prevent attackers from trying to mess with our objects. There's all sorts of reasons that strict mode is good, and we should turn it on. If any language has strict mode, we should do it. We're security folks, of course we're strict. 19, we would like to avoid HTTP parameter pollution, which is such a mouthful. So let's say HPP for short. So in Express, there's an HPP module, but there's also HPP middleware that you could use. But basically, this is where an attacker sends multiple parameters with the same name in a rec.query or a rec.body, but the values that they've added, of course, are malicious. We could also write our own code to defend against this by doing input validation on the server side with allow lists, sanitization. If our framework has configuration for HPP protections, we could do that. Libraries we could use would be Express Validator, Joy, or Zod. So there's a lot of ways that you can defend against this. I've actually had multiple customers have me make special lessons just for this, because this is an attack that is happening, especially against people that make platforms. So be aware. 20, consider using the library DOM Purify. It protects against DOM-based cross-site scripting, and it basically does sanitization. It is quite nifty and highly recommended. And it's going to be on my list of cool tools at the end. If we could use sub-resource integrity, so basically when we're going to load external resources like scripts, if we want to do it securely, like we're going to use content security policy header, but also if we use the sub-resource integrity check when we include them in our code to validate that it's what we think it is. So even if it's from a content delivery network, we should check it. It's a feature that's built into modern web browsers, and they use a cryptographic hash to verify the integrity of the external script. If you are, reading the news and watching blogs and seeing social media, there's all sorts of attacks against integrity right now that are targeting developers more and more. And so this is a good thing. As an additional layer of security, so this is not mandatory, this is more of a nice to have, you could minify, bundle, and then nonce your code. You can do this using Webpack, and basically this would be a small layer of obfuscation to try to make it just take longer for someone to get at things. It is not a defense on its own, it's only an additional layer for your consideration. We want to avoid cross-site request forgery. So cross-site request forgery is where an attacker gets the victim to click on a specially crafted link. The link assumes you're already logged in somewhere like Amazon, like a place where you would be logged in a long time, and it sends a transaction to that site and tries to execute stuff. If you pass a token back and forth with every post, that malicious link won't have it, and then it can't get at you. Lots of the JavaScript frameworks will create the token for you, but you still have to check it on the back end. If you don't check it at the back end, then there's no protection happening from passing the token back and forth, right? So we need to make sure that you actually validate that it's there. Number 24, which is hidden behind the zebra. Ideally, we would use both a static analysis tool and a linter, and then fix the things we find. So basically, a static analysis tool, or SAST, static application security testing for the marketing people, it analyzes your code that your team wrote to see if there's vulnerabilities that it thinks it can find. And then a linter tests all sorts of other things. And sometimes linters also find security things, and sometimes SAST finds non-security things, and that's nice, right? But ideally, we would have quality and security both. So, dangerous functions. There be dragons. These are things that I'd really like you to avoid. So if we could avoid these functions and just never, ever, ever use them, life would be grand. All of these render code. And so if we're going to put anything from a user in it, it's particularly dangerous. And why would we use them unless we're rendering something, right? And if we're rendering something, it's because we didn't already have it. And so generally these are used with user input or something that could have been modified by the user or something that comes from an API or some other place. And so if you find these, really strongly consider as to if you're using it, if you need to use it. And then on top of that, also be very careful of what you put in there. Check it against an allow list. Be very, very careful and test it thoroughly. 26. We should avoid using the with statement. So the with statement is weird. So it allows for a simplified access to object properties by establishing a default object scope. And while it can reduce code repetition, generally it's pretty darn discouraged. And by discouraged, I mean if you're in strict mode, it won't work because it causes a lot of confusion and it has negative impacts on code maintainability and performance. Now, that's a developer reason to not use it. Now, a security nerd's reason to not use it is because it violates something called lexical scope, and it makes static analysis completely impossible. And so as a result, it's forbidden in strict mode. And so if you're already using strict mode, you won't be able to use this. But if you see the with statement somewhere, that you might be encountering a mess and you might want to declutter. We should avoid function constructors with a string argument. So if we're constructing something and we put like a string argument in there, what do you think is in the string argument? It's probably user input, right? That's probably why it's there, because you don't already know what goes in there. So be really careful with what you would be putting in there. If we're going to construct something with a string argument, think hard and long about what is in that string argument and what could be in that string argument and how it's changed, because there's some serious potential danger there. Set timeout and set interval. These functions don't have a lot of defenses in them. They're older, and we should not be putting user input in them. We should use these with caution. I don't think they're deprecated yet, but they've been found to be problematic in various ways. And so we'd want to be quite careful about using them. If we could avoid JavaScript methods that take code as string types. So that sounds bad, right? Because variables, why is it a variable? Because we're putting something in there. Where did the thing come from that we put in there, right? So set attribute, set timeout, set interval with the new function. Instead, if we could just set the attribute directly, that would be a lot safer, like we discussed in previous slides. Okay, so number 30. We should not put untrusted data into HTML rendering methods. So I know I discussed these earlier, but I thought I'd say it again because it's fun to not have cross-site scripting. And this is the what not to do. So I was like, I'll just repeat it. It'll be great. Also, you get a picture of a really cute leopard. So that's nice. So another type of injection, prototype injection. So JavaScript is a prototype-based language, which means we need to avoid problems with prototypes, including injection of prototypes. So basically, this is where an actor manipulates or overwrites the properties on a global object's prototype, and then it goes down into all the other objects below it with inheritance. That sounds pretty awful, right? So we do this, actually. So if an object doesn't have a property directly on it, the JavaScript looks up the prototype chain to the top, and if an attacker manages to change the original prototype, like everything below it is affected. And so how do we defend against this? So this is a little complicated, but we can do it. So we freeze the default object that everything inherits from. So you do an object.freeze. 2, we explicitly create objects that don't use prototyping. So these are or, not and. We use a map instead of an object. We could do that. Or we just avoid recursive merge functions altogether. So we don't do that. We just don't do any of it. It's really up to you what you decide you want to do, but you should be aware that if someone is able to inject something into the original prototype, it'll go all the way down the chain and it'll just be quite a disaster. Number 32, let's not mess with the same origin policy. Same origin policy protects one website from accessing data or resources from another unless we intentionally share with it. So we do not want to set the same value for document.domain in order to share the information between the two pages. Instead, we want to use something like window.postMessage, but we don't set it to star because we never set something to star that is meant to restrict, because then we've just ruined it, right? Same with if we set the document.domain to the same thing for two pages. Again, we've undone the protection of same origin policy. So what we want to do is basically make sure we check the origin and validate that whatever is in the message is okay before we use it. We don't want to set things to star that are meant to restrict. Oh, yeah, and we validate the message before we use it. I said that. Okay, so number 33, true validation happens on the back end. The front end validation, so in JavaScript, on the front end, if we want to do a bunch of validation to be fast and efficient and save time, that's cool. But the final decision always happens on the server where no one controls it but us. It happens on a trusted system. We should prefer private variables over global. because they're a lot less likely to accidentally be accessed by external scripts. There's a lot of reasons that we should prefer private variables over global. It's like not doing everything as root. It's the idea of least privilege. So we should use private over global whenever possible. And now, some free tools for JavaScript. DOM Purify, so input sanitization, retire.js to check your JavaScript libraries, npm audit and yarn audit, same deal, checking your libraries, Semgrep Community Edition and horosec, and node.js scan, which will check your code and do static analysis things. Bearer, which will check for privacy things and also check your dependencies. DOM snitch. So we have a bunch of tools here. You might want to take a screenshot. It's totally up to you. This is included in the JavaScript cheat sheet. Basically, it's a summary of the whole talk. But for you, if you want a picture now, you can have it. So conclusion. So we learned a whole bunch of insecure functions. We talked about safer alternatives and safer ways to do things. We talked a lot about how to avoid cross-site scripting and how it sucks and we don't want it. We covered some free tools and we all agree that secure code matters. And so now I have some resources for you in a bright yellow screen. So I have a petition, but I don't think any of you are from Canada, so you probably don't need to see it. So you could probably just skip this one. But my books, I wrote books. Me and my mom agree they're pretty good. If you like this talk, you might like these books. I have a free newsletter that comes out every month where I give away cheat sheets and memes and articles and videos and everything. The cheat sheet is, or the newsletter every month is free. Resources me. I do all sorts of things like this all the time. So if you liked this, there's basically endless content for you if you want it, because this is my job. And now treats. So I'm going to leave this on for a bit. So this is the React cheat sheet, the JavaScript cheat sheet, and the Vue.js cheat sheet. And yes, they are gated, so you have to sign up for my newsletter. But if you like those, you'll like my newsletter, and you can always unsubscribe, and I wouldn't know. But there's over 10,000 people subscribed who signed themselves up, so it's not that bad. So some of you may want this, and it's hard to see because you're also little if any of you are taking photos, but I thought I would leave this on for a second, and then I'm going to give you the presentation slides and take questions on the next one. And so now, thank you. Thank you very much. Thank you for coming. Thank you for having me. Thank you for listening. Are there any questions?
Wonderful.